Have you ever pondered the question, is matter continuous or discontinuous? This query might sound complex, but in essence, it's asking whether matter, the stuff that makes up everything we see and touch, is one seamless, unbroken entity or a collection of individual separate parts. Consider a bar of chocolate. You can break it down into smaller pieces, right down to the tiny individual chunks. But can you keep breaking it down forever? Or is there a point where you reach the smallest possible piece? This is the crux of our exploration today, the discontinuous nature of matter. The concept of discontinuity in matter traces its roots back to ancient Greek philosophers, notably Democritus, who proposed that everything in the universe is composed of tiny, indivisible particles he called atomos. Fast forward a few millennia, and modern science has not only proven Democritus correct, but has also given us a deeper understanding of these atoms. Atoms, as it turns out, are not the smallest particles of matter. They consist of smaller subatomic particles, protons, neutrons, and electrons. And even these particles aren't the end of the line. Scientists have discovered that protons and neutrons are composed of even tinier particles called quarks. This means matter isn't a continuous, unbroken entity. It's discontinuous, made up of distinct and separate particles. But these particles aren't just floating around independently. They're bound together by various forces, forming the atoms, molecules, and compounds that create the world we see around us. Now, imagine a single drop of water. It appears to be a continuous entity, but under a powerful microscope, it reveals itself to be a collection of water molecules, each made up of 2 hydrogen atoms and 1 oxygen atom. And each of these atoms is a mini-universe of subatomic particles, buzzing around in a seemingly empty space. Yes, that's right, space. The discontinuous nature of matter also means that most of what we consider solid matter is, in fact, empty space. The distance between atomic and subatomic particles is relatively vast, akin to the distance between stars in a galaxy. But this space isn't truly empty. It's filled with energy fields that hold the particles together and give matter its structure and properties. In summary, the discontinuous nature of matter suggests that matter isn't a seamless, continuous entity, but a collection of distinct particles. These particles, though separate, are held together by various forces, forming the atoms, molecules, and compounds that make up the world around us. Most of what we consider solid matter is actually empty space filled with energy fields. This concept might challenge our everyday perception of the world, but it's part of the fascinating, counterintuitive realm of quantum mechanics and particle physics, where things aren't always as they seem. So the next time you bite into a bar of chocolate, remember, you're not just tasting sweetness. You're experiencing a marvelous manifestation of the discontinuous nature of matter.